Let's see this. The maximum number of edges in a bipartite graph with n vertices is. So we are supposed to find out what can be the maximum number of edges that can be present in a bipartite graph with n vertices, right? So assume that this is a bipartite graph, which means some vertices will be here and some vertices will be here. And if you want to have maximum number of edges, then you are supposed to have from every vertex here, you are supposed to have an edge to every vertex here, right? So how to find out this partition, which means if this total number of vertices is going to be n, now what could be the number of vertices that are present on this set, in this set, and what could be the number of vertices that are present in this set? That is what you are supposed to find out. I don't know that number. Let us assume that the number is k. If I put k vertices in this set and n minus k vertices will fall in the other set, now I will assume that whatever number of edges I get is going to be maximum. Now for that value I should find out the value of k. Got it? Now if this is the case, what will be the maximum number of edges? There will be maximum number of edges only for the case when this bipartite graph is k comma n minus k, which means complete bipartite graph with k on one side and n minus k on other side. So which means we are trying to put down every possible edge in this graph, still maintaining the property that it is bipartite, which means edges will be crossing only from this set to this set. There will be no edges inside each set. Okay. Now what is that number? The total number of edges is, for every vertex here it is going to have n minus 1 edges. Therefore there are k vertices, each is going to contribute n minus k edges. So the total number of edges is going to be k into n minus k. Now we want to maximize this value. Got it? So this is the total number of edges which are possible in this particular bipartite graph. Now we want to find out at what value of k this value will be maximum, right? So according to the concept of maximum minima, you know that whenever I have any such expression, if I have to find out the maximum value, you have to see two things. One is take that and differentiate with respect to k and equate it to 0. Now wherever you get this value, which means wherever this value is equal to 0, for what value of k, using this equation we can find out the value of k at which the value is maximum, given that the double derivative, which means d square by dk square of k into n minus k is less than 0, right? So you should verify two things. First thing is whether this one is less than 0 or not. Only when this is less than 0, this particular value will have maximum value. Now when will it have maximum value? You have to solve this equation and find out for what value of k, this one is giving us this 0. Got it? Okay. Now how to find out? Either you can solve this one or this one. Let's solve this one first. So let's try to derivate this one, k minus k square. I just expanded this. I want to derive this, d by dk. What do we get? N minus 2k. Now again derive this. See, double derivative is nothing but I am deriving 2 times, d by dk into n minus 2k. Now what do I get? This one is constant with respect to k, therefore I am going to get minus 2, which is 0. See this? Now this value has become minus 2, which means this particular expression is going to have a maximum value. When is it going to have the maximum value? Whenever this one is equal to 0. Now what is this expression? This expression turned out to be n minus 2k, which means when n minus 2k equal to 0, at what value of k? K equal to n by 2, right? Therefore at k equal to n by 2, this expression is going to be maximum. So what does it mean? If I divide the vertices in such a way that n by 2 vertices are in one side and the n by 2 vertices are on the other side, then I am going to get maximum number of edges. Got it? Okay, now based on this concept, you can answer this question. The maximum number of edges present in a bipartite graph with 7 vertices. So they are saying that when n equal to 7, how are you going to divide it, and then what could be the number of edges? So we know that we have to divide it in such a way that n by 2 vertices are going to be on one side and other n by 2 are going to be on the other side. Since it is not an even number, if you find out n by 2, you are going to get 3, right? So n by 2 is 3.5. So you can assume that n by 2 is 3 here. Now 3 you have to put on one side and the remaining 4 will be on the other side. Now how many edges will be possible? 3 into 4, which means 12. So for this one, 12 is the answer. Got it? So in case if this would have been 8, then what happens? 4 on one side and 4 on the other side, which means 4 into 4, 16. So in general, if we have n vertices, okay, and assume that n is an even number, then what is the maximum number of edges possible? N by 2 you are going to put on one side and n by 2 you are going to put on the other side. Therefore it is going to be n square by 4. So n square by 4 is the maximum number of edges that can be possible in a bipartite graph with n nodes, given that n is even, right? In case if n is not even, then you might have to adjust this, right? One is going to be plus 1 and other is going to be n by 2, then you have to multiply it, right? Okay. Now let's see this regular graph. A graph capital G is k regular graph if its every vertex has a degree k. So which means, if you see this graph, so all the vertices are having degree 2. That is why it is called as a regular graph, because all the degrees are equal, and also it is called 2 regular because that degree is equal to 2, isn't it? See this, degree of this vertex is 2, 2, 2, 2, right? So it is called as 2 regular graph. And if you see this graph, so degree of every vertex is here 3, 3, 3, 3, right? That is why it is called as 3 regular graph, right? And what about this? Degree of every vertex is 4, 4, 4, 4, 4, 4 regular graph. Now there is one important note that you have to observe here. Now whenever the degree of every node is odd, then you cannot have odd number of vertices in such a graph, which means let us assume that here the degree of every vertex is 3, right? Now if you have only 3 vertices in that graph, what happens? The total sum of the degrees is going to be 3 into 3. Are you getting this? If I have 3 vertices, each of degree 3, then what happens is 3 plus 3 plus 3 is going to be the sum of degrees, right? Now which is going to be 9, and according to that property which we have seen, the lemma, handshake lemma, the sum of degrees cannot be an odd number, right? Therefore there cannot be a graph which is k regular in which k is odd and the number of vertices are odd, which means in case of k regular graphs, if k is odd, then definitely the number of vertices should be even, right? Observe this case, k is odd here, but the number of vertices is 4, which is even. Like that you cannot find any graph which is k regular where k is odd and n is odd, right? So if k is odd, then n is going to be even, right? Or if n is even, then k can be anything, right? Okay. Now let's look at this one. A complete graph with n vertices kn is n minus 1 regular. Why is this so? Because in complete graph every vertex is adjacent to all other remaining vertices. Now what does it mean? Every vertex has a degree n minus 1. That is why it is called as n minus 1 regular. So in fact if you observe this, it is k4, isn't it? k4, and it has 3 as the degree. Therefore it is 3 regular graph. It is k5. That is why it has 4 as the degree, right? Therefore it is 4 regular graph. And next one is every cycle graph Cn is 2 regular. Cycle graph means like this. We have seen what a cycle graph is, right? So in that one, if you observe it, every node is going to have, every vertex is going to have degree 2. That is why it is 2 regular. And the next one is number of edges in a k regular graph with n vertices is n into k by 2. So they are saying that if I have n vertices and it is a k regular graph, so what does it mean? Each vertex is having a degree k. Then what will be the sum of degrees? N into k, isn't it? If each vertex is having a degree k and if there are n vertices, then what will be sum of all degrees? N into k, right? Now according to that handshake lemma, we know that sum of all degrees is equal to 2 into number of edges. Why? Every edge is going to contribute value 2 to the sum of all degrees, right? Therefore what happens to the number of edges? Number of edges will be n into k by 2. So what does it mean? If you have n vertices in a k regular graph, then the number of edges in that graph will be equal to n into k by 2. Okay, fine. Now let's see this concept of hypercube or k-dimensional cube, QK. A simple graph whose vertices are the k tuples with entries in 0, 1 and whose edges are in pairs of k tuples that differ in exactly one position. That is called as k-dimensional cube or hypercube. So what they mean to say is, you are supposed to represent each vertex as a tuple of 0 or 1s, right? Now how big that tuple should be, that depends on what k is, right? If you see q1, which means in this case each vertex should have only one bit. q1 means one bit. It can either be 0 or it can either be 1, right? 0 and 1. Now whenever these positions differ by 1, we are going to have an edge between them like this, right? Similarly, if you look at q2, the number of vertices should be all two valued binary numbers, which means 2-digit binary numbers. That is the meaning of it. K tuples means a tuple containing k values. Now 2 tuple means a tuple containing 2 values, right? So which means there should be 2 values in the which represent the vertices, and those 2 values should either take either 0 or 1. So what are the possibilities? 0 0 0 1 1 0 1 1. Now these are the vertices. Now they are saying that these vertices are related like this. If two vertices differ by only one bit, there will be an edge between them, right? Now if you observe this, these two vertices, they differ by one bit, this one, that is why there should be an edge. Now even these two differ by one bit, that is why there should be an edge between them, right? And these two differ by one bit, where this bit, that is why there should be an edge between them. These two differ by one bit, that is why there should be an edge between them. Now if you observe this, see this. Now these two vertices differ by one bit, which is second 0, that is why there should be an edge between them. These two differ by one bit, that is why there should be an edge. These two differ by one bit, there should be an edge. These two differ by one bit, there should be an edge, right? And similarly, if you go for 3, then Q3 is containing vertices in which each vertex will be represented by 3 bits, right? So either all zeros, right? 0 0 1 0 1 0 0 1 1, so on, 1 1 1. So you are going to get 8 vertices, and each vertex has to be adjacent to other vertices which differ only by one bit, right? So in general, if you take QK, what does it mean? So it means that each vertex has to be represented by a sequence of k bits, isn't it? Now k bits, and each bit can take 2 values. Therefore, how many possible vertices will be there? 2 into 2 into so on, 2 k times. Therefore, it is 2 power k. Therefore, in QK there will be 2 power k vertices. Got it? Now, what about the degree of each vertex? Now, observe this. If I have k bits, let us say if I have 2 bits, now this particular, let us say 0 0 is a vertex. How many vertices can it be adjacent to? Either this bit can change or this bit can change. Therefore, it can be adjacent to 2 vertices, isn't it? If I have 3 bits, 1 2 3, let us say there is a vertex 0 0 0. How many vertices can this be adjacent to? Either this bit can change, keeping these two constant, or this bit can change, or this bit can change, which means 3 vertices. It can be adjacent to 3 vertices, right? So which means in Q2 each vertex can be adjacent to 2 other vertices. In Q3 each vertex can be adjacent to 3 other vertices. Similarly in QK each vertex can be adjacent to k other vertices. Got it? Why? Because you are going to have a tuple of k values, right, k bits, and each bit can differ by 1 in order to get other vertex to which it is adjacent to. Got it? Therefore, you are going to get k as the degree of every vertex in QK, right? So in this, the degree of every vertex is 2, in this, the degree of every vertex is 3. So in some sense, you can also call it as 2 regular graph. You can also call it as 3 regular graph. Got it? Okay. Now what about QK? QK is a k regular graph, right? So now you got 2 points. In QK, the number of vertices is 2 power k, and the degree of each vertex is k. Now what will be sum of all degrees? Sum of all degrees will be equal to number of vertices into degree of each vertex, which means 2 power k into k, right? Now this one should be equal to what? According to that handshake lemma, 2 into number of edges should be equal to this number. Are you getting this? Degree of each vertex is 2 power k. Sorry, number of vertices is 2 power k and degree of each vertex is k. Therefore, the sum of degrees of all the vertices put together is going to be 2 power k into k. According to that handshake lemma, this number should be equal to 2 into e, which means the number of edges e is going to be 2 power k into k by 2, which is going to be k into 2 power k minus 1. Got it? So now you look at these points. Number of vertices in a k dimensional cube. So k dimensional cube is nothing but qk is equal to 2 power k. That is what we discussed, right? And the second one is number of edges in the k dimensional cube is k into 2 power k minus 1. Okay, fine.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities or 50 lakh universities, but whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.